All right, then, Diana, just let me know when you want me to start, and I'm happy to do that. You're muted.
Oh my God, I thought that at least in 2023 that will not happen. After so much experience to work remote, that should not happen. Anyway, welcome everyone to a new session. So a new year starting quite nicely. We are talking about bringing GitOps to machine learning with dstack, and our guest is Andrey Cheptsov. I hope I say that correctly. He's the creator of dstack. He's passionate about open source and developer tools. And he previously also worked with JetBrains in the PyCharm team. To be honest, my favorite product, I use it on a daily basis. So thank you very much for your previous effort in that. How the session is going to work from now onwards. So besides meeting our guests, we will also talk about the main topic of the session, which is bringing GitOps to machine learning with dstack. And then towards the end, we will have the opportunity to do networking, to meet each other, to share about our experiences, perhaps to interact with each other and get to know each other. Also, if you want, maybe even now, not necessarily to wait towards the end of the session, also you can share your LinkedIn so that people can connect with you. And hopefully in the future, there will be more opportunities. All right, that's it from my side. And then I will give Andrey the opportunity to take over, to introduce himself a little bit, to talk about how he started dstack and what's the whole background and so on.
Right, awesome. Yeah, so I hope you can hear me well and you can see the slides.
Yes, we can see the slides.
Awesome, perfect. All right, then let me begin. So my name is Andrey. As Diana said, I'm the creator of dstack, which is an open source product, which I'll talk about during the our talk. And prior to dstack, I've been worked with JetBrains. And yeah, basically spent a lot of time there, roughly about 10 years, did many things, worked with different developer tools. So worked with IntelliJ, then with DataGrip, Golang. Most recently was a PM for PyCharm and was actually responsible for data science tooling there for the support of Jupyter notebooks and all. So if you don't like something about the Jupyter notebook, so probably I'm also partly to blame here, and would love also to hear your feedback after the talk. And we can talk about that. But today's agenda is to talk about such a concept as GitOps applied to machine learning, and of course dstack, the open source tool, which I'm working on. Right. Yeah. There'll be some illustrations, courtesy of Midjourney, generated with Midjourney, but just not just to make these slides a little bit less boring. But in the end, I'll have just a few slides and then switch to the hands-on demo. In case you see something and you'd like to ask immediately, feel free to do that. Otherwise, we'll also have some time in the end for the Q&A. Awesome. Right. So we'll start with the definition of GitOps. So some of you may have already heard that concept. Some may not heard it. Might not have heard it, but basically what GitOps is, it is a set of certain practices and then tools that help drive these practices. And one of the main ones, basically it starts with using version control. So GitOps means we version the code in order to make sure that later on when something is deployed, we can track this down and we track all the changes. Second is collaboration, and this is what GitOps enables individuals and teams to do. Basically, again, through the tools such as Git and CI/CD tools, it is easier for you to collaborate as a team. Compliance is also one of their, I guess, key principles here. And well, compliance is a quite general concept. Here, what is meant is when we make changes within our code, we automate the routines of checking and verifying these changes and automating reviews and all. So by doing this, we make sure that their software which is deployed is verified to a certain extent. And finally, it is infrastructure as code, also a very important part of GitOps. And this is relatively new concept. So I guess it started mostly with Terraform. Maybe you know about Terraform, maybe not, but basically that was a tool that significantly simplified defining infrastructure as code and provisioning that infrastructure over different vendors, be it cloud vendors or even Kubernetes providers, which helps a lot reduce the problems which you might have at the production level. Right. Again, this is just an intro, so don't expect me to go into the depths of it. But it is just to introduce you to the rough idea of what GitOps is. It is basically a set of practices and tools that drives these key principles. Right. So GitOps is mostly known for traditional software development. Now, today we talk about machine learning, and it is worth to mention that machine learning is quite different from traditional software, which is why you can expect that GitOps might not be applied directly, and there are certain nuances, and it is worth going through these nuances. Again, depending on whether you've already done something like in the area of machine learning or not, you may know that machine learning involves a lot of experimentation. Basically, when you build a model or when you are about to build a model and explore data, you have to do a lot of interactive stuff, play with the data, or run certain experiments with your model to see what works, what not, and only after that you get something that is deployable. So basically, that's why, for example, if in software we typically commit our changes and then they are integrated through CI/CD platform, in machine learning, we spend a lot of time at the experimentation stage, and a lot of people spend time with Jupyter notebooks or Python scripts. And that's, for example, why version control is often hard to apply. Second is it's not just code, which is typically the case for traditional development, but there are also data and model artifacts. Sometimes you need to fine-tune a pre-trained model. Basically, you have to deal with pre-trained models as dependencies, or data with which you need either to train your model from scratch or to fine-tune your model. So that's how it is different from traditional software, where you don't typically have these things. And finally, as you know, especially with deep learning, especially with a modern machine learning, it involves costly hardware to run, such as GPU or TPU, and a lot of memory. In traditional software development, you may often find that your local machine is enough, and you can write your code locally, you can run your program locally, and much later may want to deploy that. And in machine learning, most likely you'll have to use this costly hardware from the day one, right? And as you could expect, these differences in machine learning compared to traditional software development comes with certain challenges which you face during performing machine learning. So number one, which is often the case, is the friction between different roles. And you might have heard or participate in the stories like AI researchers, for example, or ML folks, spend a lot of time experimenting with the models. And when it times comes to productize the model, what you have is a number of notebooks. And when somebody else wants to productize your models, it is extremely difficult to do, because the code is written the way that it is optimized for experimentation and for interactivity. And basically often, especially if these two different tasks are done by different roles, like ML doing experiments and developers actually productize things, we have a lot of friction. And in the end, sometimes you think, yeah, basically you have to redo this from scratch, the whole thing. Secondly, there are no great standards for versioning data and models in the market. Like in traditional software, you have certain fundamental tools, like, for example, which allow you to version packages and reuse these packages through the build systems. In machine learning, for example, we have also package managers, like, for example, we have PEEP, we have Conda, we have others. But for data and for models, there is not a lot, which is why there is no great standards for that. And basically pushing teams and individuals to use different tools. And in the end, it's very different to, you don't have a common tool, and it's not that straightforward most of the time, as you might also see it in your experience. And finally, when it comes to provisioning of the infrastructure, unlike in traditional software where we have these tools like infrastructure as code, such as Terraform or Kubernetes or CI/CD, in machine learning, for example, when you want to run these multiple experiments, there are not so many tools that actually help with that, and there is not. I would rather argue that there is no standard approach to that. So these are basically very general challenges which you see if you will do machine learning in the production setting. Right. And today we're gonna see how dstack helps deal with some of these challenges. And I'd like to start with a very rough overview of what dstack is and then how it works. Basically, dstack is an open source tool that you can install through PEEP, just like other Python packages. It comes with Python API, but also with a command line interface, basically with a CLI utility, which you can use from your terminal. And what it does, it allows you to define your ML workflows, basically things that you have in your project which you regularly run. For example, you may have a workflow that prepares data, you have a workflow that trains a model. And dstack helps you define these workflows, and then also version and reuse artifacts. For example, you've prepared data. Now you can reuse this data conveniently across different workflows or even teams. And most importantly, dstack helps you provision infrastructure. Basically, it allows you to work at your local on your local laptop, for example, on your local machine, but you may configure a certain remote environment, and such as, for example, AWS cloud or some other cloud. And then when you run any workflow through dstack, dstack will take care of provisioning that. Apart from that, you are free to use any cloud vendor, any framework, TensorFlow or PyTorch, doesn't really matter, Python or not even Python. You are allowed to use anything. And how exactly it works, we'll see in the following slides. I'll show a few slides again that guide you through the steps, but we'll just after that we'll switch to the hands-on demo where I'll show how it works in action. Right, just to introduce dstack to you. Step number one is installing the CLI through pip, basically pip install. And then, at least right now, you have to configure your remote environment. For example, you can configure your AWS credentials. You can pick an AWS region where you'd like to run your workflows. You can pick up an S3 bucket where you'd like to keep your state and like output artifacts as well, and some other.
So, Andrey, I will interrupt you briefly. So you mentioned that we need the remote bucket in order to store the state. What do you mean by storing the state? I assume it's infrastructure related, but maybe like to elaborate on this a bit.
Sure. Thanks a lot, Diana, for the question. So dstack in general helps you work either locally or remotely. If you work locally, then it's everything is stored on your local machine. If it's remote, which can be in addition to your local setup, you can configure your AWS account. And as you've asked about the S3 bucket, you can configure S3 bucket. In this case, anything you run, it is tracked in the configured S3 bucket. All the runs, the metadata, and also the output artifacts. For example, you can save some data, which I'll show you through the demo. As an artifact, for example, you run an ML workflow that prepares data and saves this as an artifact. So now you can reuse it from your workflows. But most importantly, because you have configured your remote, you can share this remote with the rest of the team. So for example, others can configure the same S3 bucket, and then they can collaborate with you. They basically can access and browse the same runs, and most importantly, they can reuse the output artifacts of your workflows, just as you can reuse output artifacts from them. For example, you've prepared data, so now anyone on the team can reuse that data in his or her workflows. Does this one make it more clear?
Yes, thank you. I want to remind people who joined that you can at any time ask questions by writing them into the chat, or you can unmute and ask the question directly, just as you wish. Yeah, feel free to do that.
Yeah, absolutely. Second one, this is how dstack allows you to define workflows. Even though we also now working on providing a Python API is an alternative to YAML, the primary way of defining workflows today is YAML.
So before we continue, I see raised hands. So
yes.
Yeah, go ahead.
Yes. I was just wondering, for the remote, does it have to be AWS? Can it be Google? Can it be Azure?
Right, exactly. So AWS is what is stable now, and we also now have GCP and Azure in work, and it's not stable yet, but basically expected to be ready within a couple of months from now.
Okay, and then for local, if you have good hardware, is it is it performing? Can it perform well there as well, or?
Right. Thank you for the question. So there are certain limitations. For example, as of now, and there are also plans to make it even better. Like for example, under the hood, dstack relies on Docker as a runtime, as a layer for isolation. and which means if you run it locally, you have to have Docker installed on your machine, which might be a problem if you are running on Windows or Mac OS, because in this case it's going to be simulation, and then you might not have their perfect performance. And we are also considering, again, in one of the next releases, to provide for local runs an option to not use Docker, but run it directly on the cloud. Sorry, not cloud, but on the local machine. In that case, you won't have any performance issues, which might be a great option, especially if you are using Mac or Windows. Please let me know if this answers the question. Awesome. Yeah. Yeah. Let me know if there are more questions, Diana. Meanwhile, I'll continue. Okay.
Yeah. So there's nothing. No, sorry. There is something in the chat. Vladimir asks, "Do I understand it right that S3 bucket is mainly to share machine learning state between team members and maybe for backup reasons?"
Yes, exactly. And we also now plan to make certain improvements in dstack in this regard. But the general idea here is this: if you run locally, then everything remains on your local machine. But if you would like something to be reused by somebody else, you can push it also to the configured remote configuration. For example, if you have an S3 bucket, it will be there. So next time somebody wants to reuse that, once that same remote configured, then they can pull this or just reuse from their workloads which they run in the cloud. Or, for example, if you run it directly in the cloud from their day one, then automatically, by default, we store all the outputs in the configured remote configuration using the configured S3 bucket. And primarily, it's for reuse. For example, if you train a model, you saved its checkpoints as an artifact. For example, if you are training it in the cloud, you absolutely have to store it somewhere. And dstack offers you a very convenient way of storing it in the configured remote, which makes it possible to reuse it across the team, and then later on to find what exactly you had, and then see how exactly you got it, and and so on and so forth.
So Vladimir says, "All right, got it. Thanks."
Yeah. Thanks for the question. So here you may see how workflows are defined. We have a concept of a provider. It's not a big deal. I can provide details later, but think of Bash as the default provider, which allows you to provide arbitrary Bash commands, where you can run arbitrary code. You may run your own scripts from your existing current repository. As dstack isolates the environment, you can install any libraries here you want. And when you run it, everything is running in the container. So, for example, by default, it provides you the pre-installed Python of the version which you want. And by default, it's exactly the version which you have locally installed, but you can change it. And then it also provides a mini Forge bundled, so you can use Conda from there, the mini Forge distribution of Conda from here. And you can even, for example, prepare Conda environment and save it as an artifact, and then reuse that artifact from other workflows if you want. This might be useful, especially when your environment is quite complex. There is a lot of native libraries installed, and that's much faster if, for example, you've prepared the environment once and then reuse it across workflows. Then you can define dependencies. And there are several ways of defining dependencies, but basically if you look at this train, it has this depth property and then tag mnist data. This is one of the ways, for example, if you run the download workflow once and then assign a tag to it, for example, mnist data, then you can reuse this workflow in their train workflow. And this is exactly what is happening here. And yeah, any workflow can, for example, save certain output files as an artifact. For example, if you look at the first workflow, download, which let's say download some data, and it saves it locally in their data folder, we say that please treat it as an artifact. Then when we run this workflow, this stack will automatically save it as an artifact so we can reuse it later. Right. And finally, it is also possible to define required resources for workflow. For example, if you want for the train workflow to use GPU or to use spot instances, you can also have this defined within this resources property. And then next time you run the workflow, this stack will automatically provision the required resources or make sure that they are available where you run it. Right, and then right now it is possible to run the workflows through the CLI. Basically, it's similar to Docker, like dstack run command, where you give the name of the workflow, and then what it does, it depending on where you run it, you can run it locally or in a configured remote, such as cloud, for example. It submits it, then it runs the commands. It automatically provides the container and provides all the dependencies. It pre-downloads the dependencies if that's necessary. And there is a lot more capabilities. Like, for example, it allows you to also expose ports if you'd like to run applications or even attach interactive environments. For example, VS Code or Jupyter Lab, you can easily attach them to these running workflows. So having said that, probably it's worth to switch to my terminal and show you how this works in action. Any questions so far?
No questions in the chat.
Awesome. Yeah, so here we go. This is a terminal. And normally I use an IDE, and most of the time I'm using PyCharm. But for the sake of this demo, I'm actually going to use terminal just to show you, just to keep the focus on the CLI and on the code, and not the IDE so much. And also to show you how you can use this stack even without an IDE if you want. So what we have here is it's a pretty empty Git repo, and we start with pip install dstack. It is already installed here, but just to show you how you typically install. Then, for example, if you'd like to configure the remote, such as AWS Cloud, you typically use this dstack config command, and then it asks you, okay, please select the region where you'd like to run your remote workflows. Please select the S3 bucket where you'd like to keep that state if you want to share them with their other team or just reuse for yourself. EC2 subnet is just to give you a choice over their VPC, and then subnet where you'd like to run your workflows in the cloud. But if you don't have preferences, you just say default. Right. So now, if you run the dstack command just without any arguments, you'll see what commands are actually available here. And as I mentioned, it's in a way it has a lot of commands which is similar to Docker. So it has the run command, it has the ps command, logs. You can also stop things. You can access artifacts, tags, and all. But for now, let's focus on the most simple stuff. So we'll start with defining a workflow. So workloads are defined through YAML within this .dstack/workflows folder, and You have workflows property on the top level, and then this is an array. For each workflow, you give it a name. Then, as I said, you choose a provider, and there are other providers as well, except Bash. But for now, we're going to use just Bash. And now that you use Bash, we may pass the commands. This is an array. Let's say we have something very simple. Hello world. Right. Good. Let me check. Workflows, name, provider, Bash commands, each echo hello world. Good. Yeah, just make sure that it's okay. Anyway, so now that we defined our workflow, we can immediately run it. And here, by default, right now at least, it's running in the configured remote. If you want to run it locally, we use that -- local. And when we do that, if there's no local runner, it will download it and will cache it for next time. But basically, it will run these workflows locally. And yeah, this one is super simple. It just prints hello world. But at least now you can see that it works. So now, for example, if we use the dstack PS, by default, it will show the last successful run. And you see that it typically has a name and some other data. But that was probably too easy. So let's try something more complex. So let's say we save it into output hello txt, and now we can say artifacts, and then we have path output. So basically what we do here is we save certain data into the folder output. For example, we create file hello txt, and we register that that path as an artifact. So now when we gonna run that workflow, yeah, obviously it will not print it to the output. Instead, it will create that file, and dstack automatically will save it as an artifact. And now we can see what we can do there. Again, bear with me. So this one is super simple. It means in real time you would probably deal with a lot of data or with some very heavy workflow. But just to simplify the demo, I'm using this hello world. But okay, so now we've run it. We can use the dstack PS commands to see. Okay, so series welcome 1. Now we have this dstack artifacts command, for example, list, and we can give the name of the run artifacts, right? And you can see that basically we save these artifacts, and it shows the file name and its size. And what we can do, for example, with it, if we really want, we can download it, but through another command. But it's more fun to actually reuse that artifact from another workflow. Let's say we wanna define another workflow. Let's say cat. Provider bash as well, commands echo, no, not echo, cat, cat output hello txt. And to make sure that we actually have this hello txt there, we define a dep to this deps property. And here, for example, we refer to the last successful workflow with the name hello. And what it means is that when we run the cat workflow, it will automatically mount the output artifacts of that dependency. And in this particular case, it's going to be the last successful run of the hello workflow. And basically, this workflow will just output the content of the of this file. So let's give it a try. Run. I'm sorry. No, I guess it was wrong.
So while this is running, there is a question in the chat. So Gaurav Kumar, hopefully I say that correctly, says that just thinking, if I want to integrate MLflow in dstack, then how can I make it possible?
Right. That's a good one. So in just to start answering this question, it is possible to use any experiment trackers with dstack, which makes MLflow just one of them, and you can actually use others as well. For example, you can use weight and biases easily. You can use also AIM. You can use Comet. You can use TensorBoard. The idea is pretty simple. Basically, you yourself decide how to use that your other experiment tracker. I guess in the case of MLflow, typically with MLflow you have it hosted somewhere, right? Because typically it's you run the server of MLflow somewhere, and you can just refer to that server from dstack. I guess that would be the case for MLflow. Compare it, for example, with TensorBoard. With TensorBoard, you won't even need another server. You could just write the output files, the event files into a local folder, and you can even mount that local folder as a real-time artifact. We have such a thing with dstack, which means that this artifact will be stored in real time as you write there, which means that you can, while your workload is running, you can attach a TensorBoard directly to the folder where this artifact is stored to see that metrics in real time. Or, of course, you can also wait and then just take these event files and then open it in the TensorBoard, but it's up to you. But basically, for example, in case of MLflow, you would basically point it to the MLflow server, I guess. Hope that helps, but also happy to provide more information. And again, also we have a Slack channel in the documentation. If you would like to know more, just ping me there, and I'll be very happy to provide additional information and help you set it up.
That's great. Thank you.
Thank you.
All right. So here we just saw that we've run a workflow cat, which reused the output artifact from the hello workflow. So let's see. We still have some time. So what we can do is see a few other check a few other capabilities. For example, I promised you to show other providers. For example, we have another provider called, for example, Code. So what we can do here is, let's say we have a dep, same dep, hello. So what we have here, we've defined the workflow called with the name ID, and we chose the code provider, and we added the dependency to the hello workflow. So let's save it, let's create it. So now dstack run ID local. Again, I'm running it locally just to save a bit time, because if we run it remotely, then typically for every workload, it will take roughly a minute to provision the workflow, the infrastructure in the cloud. But yeah, so that's why I'm running it locally. So let's see. It takes a minute, less than a minute to run. So what you already see here is that it installs the VS Code server and Python extension, and it will basically run a VS Code where it will mount the current repository, and it will mount all the dependencies. And for example, if you define any resources such as GPU or something other resources, it will make sure that this workflow have everything configured. So you can open this VS Code, configure it, and then work with your code and data and dependencies interactively. So here we go. It just prints the link. Now we click the link. And I guess now you don't see the link. So let me switch the sharing settings. So you see the entire screen because I've clicked the link. So now we are inside the VS Code, which we are running. We have this Git repository mounted, and we also have, as you see, this hello txt as a dependency artifact mounted as well. So now we can open, for example, I don't know, terminal, and
By
we
the
see
way, it's
that.
a bit difficult to see. Do you think you can like increase the font?
Sure, yeah, but there's not so much to
That's
see.
great.
Just except that basically it's a VS Code which runs our workflow. It's just to show you that with dstack you not only run some long-running workflow locally on the cloud, but you can also work interactively with your code. This is an example of VS Code, but also there are other options. One more option, for example, is to use the Jupyter Lab or Jupyter Notebooks. You can easily use them to work with your workflow. And this environment which you have here exactly matches what you've requested in your workflow, which is a big deal, because sometimes you may want to work interactively with your code, and you'd like to be sure that this environment is exactly as what you actually want to have, and you don't want to spend time on configuring that all manually through interface or all. You just define it once within workflows.yaml, and then you run it with one single command, and then you have this interactive environment provisioned. For example, you have also Python. Now you have also Conda of the exactly same version which you've requested here. Right. So let me switch back to the terminal. Let me stop that workflow. And for example, if we open here, and if I, for example, edit the resources property here, and I'll, for example, say, okay, interruptible true. For example, this means please use spot instances, this interruptible instances, and also say I want to have one GPU here. So let's see if we can run it. But in this case, not locally, but in the cloud. Again, I've requested the spot instances, and let's see if we have them available in the pool. If not, then maybe we'll change that, remove that line, and we'll use the normal instance. So let's see.
For people who don't work a lot with AWS and infrastructure, what is the difference between spot instances and normal instances? And why would we prefer
spot
spot,
instances are just, yeah, spot is typically cheaper, like 3 times. And this is a big deal because when you want to use when you want to use some expensive GPU, like for example V100 or A100, it costs a lot of money per hour, and spot instance will be 3 times cheaper. This is a big deal. Yeah, they are not available all the time, but when they are available, it's a great deal.
That's great. Thank you.
Right. Yeah. Let's see if we can use non-spot instance, because it now says that spot instance is not available. Yeah. Yeah. Any questions? Meanwhile.
No further questions in the chat.
Right. So while we have this workflow provisioning, which typically takes a minute, let me show one more thing, which I promised to show. Let's imagine that we want to run not just a job, but actually an application. Let's say we have some interactive application. Let's say, I don't know, Streamlit. Streamlit. Hello, Streamlit. provider bash commands pip install Streamlit, Streamlit hello server port. We can request ports, any number of ports. In this case, we'll request just one. And as we requested, it will be possible to pass these ports as environment variables to our workflow. In this case, we pass it through the port _0 environment variable. And then we also bind it to the any IP address. And then also, for example, let's say server headless true. This is how you typically run a Streamlit application. We just point it to a very specific port, make sure that it's not bound to one particular network name, but basically it works with any. And then we also say that don't run the browser, wait for us to open the URL. So hello, Streamlit, all good. Yeah, it's still running. So what we'll do is we quit and then we run, what is it? Hello, Streamlit, right? Let's run it locally. May take a while, but what we're going to see is that it will install Streamlit as a part of this workflow, and we'll basically run this application, and we'll be able to open this application and work with it interactively. By the way, it's already started. This one will take a minute, but for now, switching to the Streamlit one. Here we go. So now it gives us a URL. Now we open that URL, and basically that's our application running. So we don't need any Docker. We don't need to do anything manually. We just write 3 lines of code, and then we can run it either locally or in the configured cloud. Right. Let me stop that. And when we run something in the cloud, as soon as the workflow is finished, dstack takes care of churning down all their not used instances. Here we go.
Another question that we have is: does dstack version config file? Probably there is a have in between that was missed.
Sorry, say it again.
So there's a question. Does dstack version config file? Like, I assume the question is like, does dstack have a version config file?
I would maybe clarify what version is meant there.
Yeah, so the question basically is like every time we change the config file right here. So does it possible for us to check version the config file over the time? So maybe if we want to roll back something, possible.
Mm-hmm. Just to clarify, do you mean workflows.yaml file where we define workflows?
Yes, definitely.
Yeah, so when we change it, when we run any workflow, dstack tracks the changes, even not committed changes, and remember them. And later on, you'll be able to basically see these changes for every workflow, what exactly was the revision of the repository and what were the local changes there. I hope this answers that, right?
Yeah, okay. Thank you.
Yeah, basically it means that it tracks everything. It tracks everything and remembers what change were made. Yeah, and now that we see that, so what we did in the terminal, we launched that ID workflow, and we requested 1 GPU. So now we have this workflow running, and we see that GPU is available here, so we can work with it, just to show you that it provisions exactly the resources which you asked. And for now, I'll just stop that workflow. I guess it's that is it for this quick demo. But again, the demo was very simple, just because we want to simplify the demo and not overcomplicate it. For example, if we used a real ML project, we could maybe, I don't know, just wait for the entire demo while our model is training. But it does mean that you cannot use dstack for real project. Basically, it's done for real projects, and it is designed for very heavy workflows. And the general idea is that compared to other solutions, the focus here on the simplicity. You can work with your terminal, you can work with your IDE, you can use Python scripts, you can actually, if you want, use notebooks. But the idea is that you define your workflow once, you define the dependencies at all within this within your repository, and then you can easily run it everywhere. And on top of that, of course, it versions everything if you want, and allows you to reuse that. For example, you are working on some Kaggle experiment, let's say, and you typically start with a pre-processing data the right way, and you do it several times to see, okay, so this time actually you've done it right. So next time, then you can assign a tag to it, and then you can focus on the experimentation, on training your model, and you just reuse the artifact of the data. And it keeps everything within a configured remote environment, for example, in the S3 bucket, which you configured, and you can bring other folks to collaborate with you. Yeah, all open source. So basically, there is a small team behind that project, and we are committed to keep the project truly open source. And we actually have a lot of stuff in our roadmap, including the user interface and all, and that all going to be in the open source version. And of course, not to mention the GCP and Azure to be supported as well pretty soon. And there is a GitHub where you are encouraged to give us a star, but more importantly, to give us feedback. And there is also Slack channel where you can share anything, any questions, any help requests, and we'll be happy to help.
That's great. So you mentioned that, of course, this is an open source project. Like, how can one contribute? What kind of skills does one need to have in order to be able to contribute to this project? And perhaps also you can share the links to where exactly can one contribute and find the project.
Right. Give me a sec. I think that's a good one. Right. So here we go. First of all, here's the link to the GitHub, most important one. There you can find the link to the documentation and to the Slack channel. Slack is a great place to ask questions. And for example, if you'd like to contribute and you don't know where to start, Slack is the best place to start, and we're gonna help you get started with that. And Diana, as you mentioned, that like what are the ways to contribute? So lots of ways. Starting with some things where you won't even need to write code. For example, documentation is one area, and if you see that documentation misses something, which it does a lot, basically there's a lot of ways to improve the documentation, and we also work on that, but you can help. That might be a very valuable contribution. And you can also contribute with doing some tutorial or some demo or talk like that about dstack. That might be an amazing contribution, way to contribute. And of course, there are certain issues in our issue tracker on GitHub, and you can also use the special tag like first good issue to see what are the easiest way to get started with contribution. And if you cannot find something, also please write to the Slack channel, and we'll reach out and and then help find areas where you can actually contribute.
That's really great. Thank you. I want to remind everyone that if you have questions, you can just unmute yourself or you can write them in the chat. And there's actually one question right now. I think it is super nice that this is open source. I wonder how is the business model for a startup that supports an open source project? I cannot see in the website a paid version. Is there something like that?
Yeah, so that's a good one. I guess it's a challenge for any open source projects to monetize it, and we are open to explore this area more. So luckily we are not in a situation where it's like super critical right now, but we open to different ways to do that. But again, trying to be also very much transparent. One way, for example, which we consider is also helping enterprises, for example, build in certain stuff which is, they don't want to spend time with. Like, for example, we have with some customers where, for example, they ask for things which you don't want even to see in the open source version. Like, for example, they typically ask like, can we have some reports? So basically they have multiple teams and they want managers to see, okay, which team is working on what stuff and what are the quota for every team, and they want to have a rich system of approving that quota and different kind of alerts. Some other folks wants to have a way to some additional user interface to run these workflows and schedule that stuff. So the vision for dstack is to provide a platform with an API which you can use to extend the platform, but the most basic stuff is going to be available just right out of the box. So basically, within a couple of months, we are going to release the user interface where you'll see things and be able to basically, for example, work with different repos, create multiple teams, and administrate that. But also we actually want to provide a Python API which you can use to extend and build other things on top of this stack. For example, for some team, you'd like to build a, I don't know, let's say Streamlit application which allows you to run trainings and allows you to select certain stuff through the user interface without writing any code, basically submit different kind of experiments. This is very, very simple thing that you can build if you have Python API, and we want to provide that Python API. But basically, if we monetize the platform, we will monetize through advanced features which you don't typically want to see in the open source one. Hope that helps, but if you have some ideas in this regard, please feel free to reach out.
Thank you, Sebastian, for the question. There's a second question from Deepak. I'm sorry I missed some part of the session in the beginning. My question is, does dstack spin off a Docker image behind the scene to run the workflow task?
Yeah, I mentioned that very briefly. Basically, right now, under the hood, dstack relies on Docker. And depending on the provider, it might use different Docker image, but we also basically considering now a way to not directly rely on Docker, and especially when you run it locally, we want this to be super lightweight and friendly to your native operational system. For example, you may want to use your GPU from your silicon Apple Silicon. Or if you have Windows and you have special video card which you can use, want to use, yeah, basically, probably there'll be also a way to have it without Docker. But again, if you have some specific feedback in that regard, we would love to hear.
And the further question, also thanks from Deepak. And huge thanks for creating this stack. That's very wholeheartening to hear, I guess. Okay, there's another question. So Gaurav Kumar is asking, I am just trying to differentiate dstack and Airflow. Your comments on that will be highly appreciated.
Right. I guess there is a lot of changes, differences, but if I highlighted the main ones, I would say the following. First, dstack is focusing on machine learning, where Airflow is more focused on data engineering and then data processing. And in this regard, dstack would be a better fit if you are doing machine learning and if you process data as a part of your machine learning journey. For example, if you process data, then it might be much easier to have one platform where you process data and train models and version stuff the same way and have it defined the same way. So that's one thing. Basically, the focus is on machine learning. Secondly, I guess we have we designed dstack slightly different way in terms of the artifacts. So basically, with dstack, artifacts are the first-class citizens. In Airflow, with every workflow, you define yourself where you want exactly to put it, which folder, which destination. With dstack, you don't think of any destinations. You just say, just process data, and dstack stores it in a central way and allows you to conveniently reuse that the very same way across any other workflow or project or team. I hope that helps. But again, I invite you also to the Slack channel where I'd love to provide more examples and more information.
So I hope that answers the question. So yeah, Gaurav Kumar said thank you. Okay, are there further questions, impressions, or suggestions that you would like to speak up about?
Thanks everyone for the questions and for kind words.
Yeah, there is a further question actually. I couldn't find the documentation for integrating with weights and biases. Could you please share how to do it? A link to the doc is great.
Yeah. Thanks a lot. Shame to mention there is no such a page, and that's just if I don't know if you are open to contribution would be actually great one, and I can just right after this talk will create a GitHub issue to do that, and we'll mark it as a good first issue. So in case you are curious about the contribution at all, it's a great one to basically to contribute for. But apart from that, if not, then basically you're right that it's great to add it. So basically we'll if no one picks this issue, we'll basically do it ourselves. And having said that, just mention that basically using weight and biases is super straightforward. You just configure your weight and biases token as a secret. If you are using remote, and that is it. Basically, you just submit your metrics using the weight and biases API. But basically, that needs to be covered in the documentation for sure. So
Deepak said definitely interested to contribute, and again,
awesome.
It's quite nice to hear something like that. Yes, I agree. Further questions from the audience? Okay, it doesn't look like that. Andrey, I thank you very, very much. It was quite an interesting session. Again, like as you said, we can elaborate even further and look into more details. And actually, to deploy like a machine learning project will be quite an interesting use case. I would personally also like to see that. Massimo also says, keep up with the good work. And Deepak says, thanks, I will give it a try to reach out to you. Oh, by the way, regarding reaching out to each other, why don't we share the links to our LinkedIn profile so that we can connect and keep in touch even after this event? I will do that as well. And of course, now we have the networking session where we can unmute, we can also turn on the cameras if you guys feel like this. And we can just talk, I don't know, about dstack, about other topics, whatever is interesting to you. Feel free
Thank you, Diana.
Thank you, Andrey, again. Jiro say that this was a very enlightening session. I totally agree with you. I also found it quite interesting.
Yeah, thank you. Really enjoyed it. And meanwhile, we'll send friend requests on LinkedIn.
Yeah, me too. Yeah. Yeah. So yeah, we have time right now. Like anyone wants to share anything interesting, something you read that was insightful and think it's nice, or maybe you want to elaborate further on dstack if somebody has further questions, maybe.
Yeah, let me know if there's anything you'd like to either hear more or comment on something.
Hi, can you hear me?
Yep.
Hello, Andrey. Hello, Diana.
Hi.
All right. So I am
Hey, Joe.
Joe. Yeah. Glad to be here again. Thank you for this session. About what you said about the issue, raising the issue with the weight and bias integration, I would like to pop on that. So once you raise the issue, I'll be on the lookout on GitHub on the GitHub report and all of that.
Awesome.
Once you raise the issue, I'd like to help on that. So that's my contribution. Aside from that, it was nice. I've been following on this side. Like I got distracted at some point, but I came back and I enjoyed the session. I think this is not the first time I'm using dstack. First time it was a little bit. I didn't really get it, but like right now, I kind of like get the idea and how to use the workflow. So thanks for the session. Yeah.
Thanks, Azure. Really great to hear. Yeah, and yeah, great on their weight and biases issue. So yeah, I guess so. I assume you are already on this lecture now, right? So we can also pick it up from there.
Okay, sure, no problem.
Right, further topics, further ideas. Perhaps something you would like to share, somebody from the audience, or maybe also you, Andrey. Maybe you have something else to say, or like you read something interesting recently and have an opinion about it.
Good one. Actually, I don't think actually I've started reading this year. Basically, I typically read quite a lot during the year, but this year, I guess it's already like almost end of March. But no, I didn't do any reading. But curious to if anyone can recommend something. I have a couple of recommendations from friends for example about ML. And that's on my list. But happy also to hear if someone wants to recommend some great book about that as well.
I know at least a few people who are reading a lot in this call, so feel free to share your recommendations in the chat or by unmuting yourself. But I wanted to also follow up on that because I feel like by developing dstack, you have to always be on board and up to date with everything that is happening in the space. How do you keep up with that, Andrey?
That's a good one. Well, again, being entirely honest, I don't think it's easy to keep up with things today because there's so many things going on. I certainly don't have capacity to follow the recent development in the research space, and then only find time for very specific things, like for example stability diffusion or some GPT development, or but I certainly don't have the capacity to follow all the cool papers. That's for sure. I spend a lot of time, of course, talking to folks that actually involved in training models, and of course I try to keep an eye on the tooling, and I typically try to check out new tools if they appear. For me, it's also very difficult, I would say, to monitor everything. So, for example, that's why I'm most of the time actually is focused more on the model development and not, for example, model deployment so much. Even though I know that there's so many things actually appear, which is great. So yeah, basically, my recipe here is to focus on things where I can have an impact, or I think I can have an impact, basically. Which, for example, in my case, it's tooling and it's model development. I guess so. I also seen the question from Deepak about what was the motivation for dstack and what time it took to get into this state. Thanks a lot. I mean, it's a good one, so I can. Yeah, it could take easily an hour to answer that, but if I do it very quickly. So I see a lot of struggle, like watching how teams actually train models, and typically I see two general ways of doing that. So one way is when folks basically they don't have an internal platform that automates all of that, and they not into these shiny MLOps platforms here and there. So what they typically do is they simply connect through SSH to the server, and they check out the code there, and then they run things, and then they keep the session alive to see how it's going. And basically that's the way of running experiments. Let's say it's at scale, which involves a lot of manual work, and then basically you have to create these instances yourself, or you have somehow to automate that, and then often you might not find strengths to basically go and automate also versioning of stuff, and basically you just put something to the folder and give it a name and then forget what was that. So there's a lot of problems around this. And then there are other teams, for example, which actually use the platform which company has a standard. For example, there's platforms such as SageMaker, there's Vertex AI, there's Azure ML Services. And I see many teams, for example, which use this platform simply because it's a great tool to use within the entire enterprise. And struggle there is typically you have to deal with one vendor which logs you in, and for example, you have to use all the tools from that vendor for everything. Basically, it's end-to-end. For example, if you're using AWS SageMaker, you have to use it for deployment, you have to use it for experiment tracking, you have to basically write the code that it's friendly for SageMaker. So, for example, if you before that used another vendor, you would basically have to rewrite your code often. And also often you are pushed to use this vendor's web-based interface and do a lot of things from the interface and click a lot. And this is not so much simple anymore, and you are not spending a lot of time within your favorite IDE, and then you don't have a lot of stuff versioned and easy to reproduce. So basically that's where the things I thought there must be a tool which is a developer-friendly one, which is simple, which you can use from your favorite IDE, and which allows you to use multiple vendors easily, and which would just focus only on this model development. So that was the idea. I guess I got a lot of inspiration from DVC and from CML, from folks from Iterative AI, I guess. It's just that when I started working on dstack, I rethought a lot of design decisions that, for example, they took, and reconsidered a lot of things. But the general idea was there to simplify. Basically, again, the idea for dstack is to provide a best-in-class open source multi-vendor tool for model development. So it's very easy to run and reproduce and collaborate. But sorry for taking a long time, but curious to see whether it resonates with you, or whether it's not, it doesn't resonate with you, or maybe it raises more questions. So if you have any comments, please speak up.
Thank you very much. I hope that answers Deepak's question. Yeah, like when he asked you about motivation, I was also thinking, like, how many people actually worked on developing this this tool?
3 folks right now, including me.
Mm-hmm. And then is there a lot of contribution from external, or it's mostly internal work?
Right now, no, there's not a lot of contribution from external. We've open sourced in October, basically 4 months ago, and we were not really focused into that. And there's a lot of things to be taken care of in order to start onboarding the contributions more regularly.
So how comes you just open sourced 4 months ago? Why were you not open source from the very beginning?
I guess we did a lot of experiments, and we did a lot of stuff to see what works, what not, and to understand what is needed and how it should be defined. So basically, and yeah, I hadn't answered that. We started working in the beginning of the previous year. So basically more than a year ago now. And the idea was to see how, basically we didn't have that, very specific idea of the product. We rather thought, okay, so there are certain problems which we want to solve, and that's how we got started. And we did a lot of experiments in terms of, okay, so actually we started with self-hosted runners, which you run on your machine, and then you can submit your runs, and this workflow is running on that self-hosted runner. Back then, we were thinking that it is going to be the primary use case. In fact, we've seen that now cloud adoption grows very fast, and we see that the biggest value actually comes from the cloud. Even though self-hosted runners, for example, would be amazing for computer vision, when cloud adoption is not that straightforward. For example, when data sets are so huge that it might. But basically, answering the question is we've open sourced last year because in October last year, because then we understood more clearly what exactly we want to build and what form should it take. But basically, we did a lot of experimentation before that.
That's to be expected, I assume, in the world of startups. Yeah. Thank you very much for answering my question. Are there any other questions, any other ideas? I have seen that Rivash has shared a book. He says he's been reading, listening to Product-Led Growth, as it seems to be a hot topic. So there's also a link if some of you are interested in checking it out. It's very nice. Thank you for sharing, Rivash. So yeah, we have around 9 to 10 minutes left in this call. So maybe some final thoughts, some final questions you might have, some final things you'd like to share. Any of you, that would be very nice to hear from the community what is interesting. Also, let me also know if there are some topics or some technologies you would like to hear about. I can also think about inviting someone over for the next meetup editions. But generally, if you have some thoughts or ideas on what you'd like to see as the content of this series of event, please let me know. So there's a question, what you advise students like me for 2023 in terms of skills? So, Andrey, would you like to take that question?
Yeah, good one. So, yeah, I'll sound as very old person now.
And you will say COBOL?
No. I would say the following. So, at least in my view, it doesn't really matter if it's 2023 or not, and what skills are popular. I would just say that it is very important that you make your own mind about the area where you'd like to grow professionally or make an impact. Pick that area thoroughly and try to dedicate yourself towards it, and then spend some time to understand and to read some fundamental books and to talk to some folks in this area to learn from them. But more importantly, to try build some stuff yourself. And at a certain point, when you're ready to grow, take some internship or take some working student job, but work for some company that is doing something which you think is great, and company that might help you quickly grow the expertise in that area. So optimize for growing, yeah, and for learning.
Yeah, that's good advice, not only for students. It's applicable to every one of us. There's another question asking if there is already a meetup already planned. So there is no next edition already planned, but as soon as I will have any updates, I will immediately create an event on meetup.com so that you can be notified and can already plan to join. So regarding what Andrey said, so Gaurav Kumar said, sounds great, Andrey. It's really fascinating things you mentioned to focus on area domain. Thank you. That is true. With that, I agree a lot. Yeah.
Just don't build ChatGPT.
Okay, all right, we're going there. So why? Why not? Why not to build ChatGPT?
Because probably everyone else is already doing that by now.
Yeah, very likely. Yeah, to be honest, like we didn't talk about it, but it seems like everyone is talking about it. ChatGPT is taking over our jobs. So whatever we learn today, it might be as well useless because we are going to be jobless and then AI will take over. Yeah, but no, seriously, like what's actually, I do have a question that I have written down. How do you think ML will impact the world in the next 3 to 5 years? So I did think that ChatGPT is already impacting it in many ways. But in general, like how do you think the world would look like in 3 to 5 years? I'm not asking 10. 10 is difficult to answer, but 3 to 5 should be possible.
Yeah, well, yeah. I mean, I don't typically like answering questions like that, but okay. So I'm in the spotlight, so let me do that. I'm afraid, actually. I'm personally afraid of the future in a way. I'm fascinated and thrilled, but also afraid because we actually see how the world is changing. Actually, we see this tremendous impact that this kind of models they have over the content, the generative models. It's even difficult to predict, but what is certain is that it will drastically change a lot of things around how basically what, for example, in Twitter you can read a lot of predictions like a significant chunk of cognitive process will shift from biology to basically compute. So we're going to see this increase in the amount of cognitive process taking place through the models. I guess that's is quite, in my view, certain. Means, for example, most likely that next year, if you call support, you'll be talking to a model. Or if you write to support, you'll be talking to a model. And if you're talking with someone, probably it can be not certain that you are actually talking to a human. Or if you read something that it's going to be like 90% that it's not written by a human.
Yeah, Deepak says that maybe it will be like models talking to each other. Very likely, very likely. Yeah, I agree with that. I think that things are going to change a lot. I think we are not yet prepared to really see how things are going to happen. There are a bunch of ethical questions in the middle. Like, we still don't yet know how to regulate certain things. I think I have just read a news title that Getty Images is suing, I don't even remember whom, but somebody who created an image generator software for having scraped their data and use it as training model, as training data, and therefore somehow the rights, the copyright somehow would therefore belong to Getty Images. We don't know what will happen in this sense. I think that we have to have a regulation sometime in place, but it's going to be so fun to watch. I think it's exciting, scary a little bit, but for sure entertaining. Yeah. Okay, we have one last minute. Any further questions from anyone? Okay, so the last question then from Vladimir: are you concerned about ChatGPT that it creates reality but actually not answering queries sometimes?
I guess that's it. This one is simple. There are already a lot of ChatGPTs, similar projects going on, and there's a lot of folks that predicts that ChatGPT will be simplified in a way that it runs within one single GPU, and that there'll be thousands of ChatGPTs hosted by different vendors.
Okay.
And half of them probably will not always answer queries.
Yeah. Very likely, yeah. And on this positive note, I want to thank Andrey again for having been a guest to Machine Learning for Production, for having delivered such an interesting session, and also to every one of you who joined, who asked questions and who wrote stuff in the chat. It also made things quite interesting. I personally felt quite entertained, and I felt like I have relaxed with my friends somehow. So that's really nice. Thanks a lot. Good night, everyone, or have a great day to somebody who joins in a different time zone, or good morning in that regard as well. And thanks a lot, and wish you a great time, everyone, and see you in the next editions of the Machine Learning for Production meetup. Have a great time. Ciao, ciao.
Thanks, everyone. Thank you, Diana. See you, folks.